first thing is, I want to be able to evaluate this nice and quickly and be able to refer to what I'm doing in a succinct way. So I'm going to start by letting this into the f of x. Right? So if you're talking about f of 1, f2, and so on, you've got to say what f is, right? So don't skip this step. Great. Okay. Now we already were told in the question that there's a root between 1 and 2. So all you have to do for part A is test out f1, which gives you, what is it, 5? Minus 5, sorry. Okay, just evaluate that. And f of 2, which I think should give you 6. Yes? Yeah, okay. And now you sort of just have to do a little bit of a flourish to explain what you're doing. Okay, so you've got your change of sign. That's all you need to establish, right? So you'd say, since f is continuous, okay, there must be a root between 1 and 2. Or a solution. Okay, now, to actually work out what it is to some kind of accuracy, right? I'll let you work out when do you think I should stop, okay? How many times do you think I need to do this before you can say, yeah, 1 decimal place, I can be confident, okay? So between 1 and 2, I'm going to bisect, right? Hence bisection method. So let's test out 1.5, okay? What does it equal to? Yeah, good. Okay. So since that's negative, which way am I going to have to go, right? Where have I limited to now? Is it between 1 and 1.5 or 1.5 and 2? Yeah, so you always want to match up the ones with opposite sign, okay? So I'd say, therefore, the root or the solution is between x equals 1.5 and x equals 2. Okay, so this is a pretty long form way of writing it, but it's pretty thorough. So anyway, now I'm going to bisect this again, right? So 1.75, and you get some other number. Let's see. It starts getting a little decimal places start to get a bit crazy. So I think is that what you get when you test out 1.75? Yep. Okay. So therefore, now I can say the roots between where and where. 1.75 is positive, right? And the one I had before, that's negative, right? So I can match it up between those two. Okay. Do I need to go another step? I kind of think that step's enough. Let's just illustrate it for sure, because when you look at, by the way, it's not just knowing that they're negative and positive, okay? Because when I look at these two values, I can also know which is it closer to, right? See how this is quite a bit above, right? So what does that correspond to? The kind of graph, right? You got minus 0.875, so here, and 2, right? Sorry, not quite that far, right? So you've got one value here, one value here. So probably, unless it's like some kind of weirdo function, right? I can reasonably guess that it's going to be closer to this side than the other side, right? So in other words, I'm guessing it's more like 1.6 than 1.7, okay? But just for the sake of it, let's do it one more time, okay? So what's halfway between there and there? What is halfway? 675?
2.5.
2.5, thank you. Okay, I haven't gone and calculated that, but what do you get?
0.56.
Thank you. Okay, so you can see the kind of accuracy you get is reflected in how small these values are. So the closer I get to 0, the closer I am, right? So this is positive, so I'm between these two now, right? So the root must be between 1.5 and 1.625. Okay, so at this point, they're pretty even. If I had to bisect it and say right in the middle, that's closer to, I want 1 decimal place, right? 1.6 than 1.5. Okay, so I would say x equals 6 is an approximate solution. Okay, and for those people who did go further, you can see I think it's like 1.58, blah, 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 blah. Okay, so it does kind of work, right? one of the great things about this is that this method that we're going through, right, it's very, very simple, right? A computer can do it really well. And so if you ever go to like, Wolfram Alpha and that kind of thing, you're like, hey, solve this, right? In general, because what they're giving you is actually it's usually an approximation, especially if it's Guido functions like this, okay? They're just going through this method, right? Because computers are really good at this, okay? They don't know some special information like, oh, they've got the cubic formula. They don't do that, they just go through this, and eventually they get to a level of accuracy that they're happy to just give to you.